On the Bateni Math Tournament 2021, Algebra number theory, problem number 2. We want to solve this problem. I solved many problems and you can use the card on top of the video and in playlist Harvard MIT. There are many problems I released of 2022, 2021 and use them to improve your problem solving. And please subscribe my YouTube channel and turn on the notification to have next videos. So let's solve this problem. Compute the number of ordered pairs of integers a, b with a and b are between 2 and 2021 that satisfy the equation this. For solving these types of problem, there is you can do two things. For example, when you see log b, you can raise b to the power of that. One idea is this, or for both sides, or you can take log from both sides. Here you can, for example, take log in base a from both sides, so it will be what? Log a. So this idea is useful in many problem of logarithm. Log the left side will be what? This one, -4, and right hand side will be this, b to the power of log a, b a minus 3. There are around 15 important formulas for log. Let me tell you some of them that is useful here. I only tell you the things here we need. If you have, for example, log a and b to the power of, let me write am, for example, an bm, then it will be what? mn log ba. Here we need that. Okay, so for this part, log in base a to the power of something, m, it will be what? It's the number that if a raised to the power of that, it will be a to the m. With this definition, you can solve them easily. It is this. So here, because by using this, it's a to the power of this, so it will be log b and a minus 4 in base b. And this part will be what? You should use this, b to the power of something. So you take power in front of that, log, so it will be log a ba minus 3 and log ba. So here it's what? -4. Again, we use this, we take -4 in front of log, it will be log ab, and this part. Let me tell you another formula that is useful. If you can have log amn, it will be log am plus log na. So here it will be what? It will be log ba plus log a minus 3a. Okay, so here it will be log ba. Okay, now if we solve this problem, let's see what we have. Here again, if we use this part, it will be, so these 3 points, as I said, there are around 10 or 15 important ideas in logarithms that are useful in AMC, American Mathematical Competitions, and other Olympiads, BM1, something like that. So here I say what this part is what, by using that, is -3. So if I call this one x, it will be x. Another important thing is, I just tell you that it has general form, but here we only need that. Log ab is 1 over log ba. So here by this it will be 1 over x. So let me write -4 over x equals x minus 3 times x. And if we multiply both sides by x, it will be -4 x minus 3x squared. So here it will be what? X cubed minus 3x squared plus 4. Again, let me tell you one important idea that is useful in many problems. The idea is useful also in all national Olympiad from qualifying level up to IMO. It's so much useful idea. Look, for degree 2 and degree 1, for degree 1 it's obvious. For degree 2 we have quadratic formula and we can solve it in all ways. So here When the degree is greater than 2, one of the most useful idea, we have many ideas, one of the most useful idea in 90% of the problem it works, is to find one root. So here, let's check, for example, 0 plus minus 1. Here, if you check plus 1, it doesn't work. If you check minus 1, minus 1, minus 3, minus 4, plus 4 works. So because x minus 1 works, so one factor is x plus 1, and you place x squared, it will be x cubed, x squared, minus 2, minus 4x. You should place to minus 4x squared plus x squared will be negative 3x squared minus 4x plus 4x will be 0 and plus 4. Okay. So this will be x plus 1, x minus 2 squared equals 0. Okay, so here we conclude what x was what, log BA. Log BA, which is x here, is negative 1 or 2. So in the first case, it's the number log BA is the number that if a raised to the power of that, this definition, memorize this sentence. Log BA is the number that if a raised to the power of that, negative 1, equals this number, b. And here a squared b. So in this case, 1 over a is b. The problem says what a and b are what numbers. If you check, a and b are ordered pair of integers, and that satisfy this between 2 and 21. So this case is impossible, and we have contradiction, so we should consider this case. A squared equals b. So we want to find this case. So here, look, for example, you can say a is 2, a and b. A is 2, 1, 1 is impossible because there are at least 2. 2, a is 2, b is 4. A is 3, b is 9. So we should consider until what squared is less than or equal to 2021. So it's good. You can check some numbers, but let me tell you a so much easier way that is so much useful. You should know the algorithm to find 2021. If you had any question about this algorithm, send message to my WhatsApp number in the description and comments. From right, you should consider 2 digits, then 2 digits. What squared is less than 20 and near to that? 4 squared, 16. 421. You multiply 4 by 2, 80. 80 what times what? You should place same number here. 85 times 5 will be 425. It's not good. 44. 4, 4, 16, 1, 4, 8, 32, 33. And we don't need to find that. The remainder is 44 point something because the remainder is not 0. So you should calculate, the last one is 44 and 44 squared. So how many answers did we find? From 2 to 44. So 44 minus 1, 43. So the answer of this problem is equal to 43. You can use my playlist on top of the video to see other Harvard problems, also other national Olympiads, IMO international level. And if you had any question, feel free to send message to my WhatsApp number in description and comments. Also, please subscribe and turn on notification for having next videos.